Hey everybody, this is Larry. This is day 24. Yeah, of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. And the contest is in like a couple of hours. So yeah, good luck to that if you're watching this before that. Okay, so today's poem is design underground system. Okay, what does that mean? It's a medium, it's what it means. Okay, so you have to check in, check out, get average time. Okay. Directly, okay. Yeah, I mean, I think this is pretty straightforward. So the key thing to know for this problem is just that average is you go to sum over count. So that means that you just have to keep track of, yeah, you have to keep track of the total and just the count, right? And everything else is just what I call bookkeeping. And bookkeeping, it's not an algorithm or technique. I get that sometimes as a comment question. And bookkeeping is just keeping track of your book. So that it's accounting term, I believe, in general. But it means basically keeping track of everything and how they all go together, and then together at the very end, show it in a cohesive way. So let's get started. Let's see. So basically, what we want to do is we want to keep track of a user's ID. Again, this may be an interesting system design question if you want to talk about scalability, but maybe not. I don't know. Yeah, so basically what we want to do is for check-in, we want to keep track of this person's check-in station. So let's do that. Can they? Oh, I was going to see if you can check in multiple times, but yeah, but okay. So let's say self.people ID. Go station name, oh, and there's a T. Okay, so yeah, let's maybe do something like that. We just do self.people is equal to, oops, typing is hard, and maybe you can assert that ID not in self.people, something like that. It seems like that would be a good thing to assert. And then check out. Now, what do we want to do in checkout, right? Well, we want to keep track of these station pairs, so let's do that, right? Like previous stop and time, previous time is equal to self.people ID, something like that. Assuming that, I'm just checking to see whether we need to verify, like. I guess assert that ID is in self.people. Also note that ID is kind of a function in Python, so it's a little bit of an awkward thing to use, but that's besides the point. So now we have the previous stop and the previous time. So then now we can keep track of two things. One is the sum portion, and then the other is the count, right? So here, okay, we'll do this again. So that maybe station pairing or something like that. Maybe I do a collection default dictionary of, and I'm using a I'm using a tuple here, but feel free to use a name tuple as well, because a name tuple probably would make it a little bit easier for you to understand it. But yeah, but then now. But basically, I just want to store the total and the count is the idea. Okay, so then now self.station pairing of previous stop and the current station name. Oops, this should be this. So we set that is equal to, I don't know, say new total, new count, right? What is new total, new count? New total is equal to, maybe I write it in a different way, but previous total is equal to this, and previous count is equal to this from here. And then I feel like I'm writing this very verbosely, but so we add it to t minus previous time for the total. Ooh. And then new count is just increment by 1, and there we go. And then at the very end, we want to do the same thing, which is total count is equal to self.station pairing of start station and station. And then maybe we want to assert count is greater than 0, otherwise you have division by 0, and then you return total minus or divided by count. And that's pretty much it. It's just a lot of keeping track. Let's see if it's very easy to have a typo because I have so many things. But yeah. I didn't know. I wasn't sure that I can do. Yeah, I mean that's fine. I just wasn't sure the syntax here for. But yeah, new count. Oh, new count is you go to previous count. Here's +1. It looks good in terms of accepted. Let's give it a submit and hopefully that's good. Oh, apparently I got one wrong answer before, and this time wrong answers again. But I mean, this assert is fine because oh no, this assert is not fine. There was one case that I was thinking that I forgot, to be honest, which is that when you check out, I was thinking about it and when I was explaining it, but then by the time I finished typing the line, I forgot about it. So here we have to do, so you have to check people out. So we have to delete this, is the idea. How do I get this in? Wow, that's a big thing. But that's a silly mistake actually. So I'm a little bit sad by this. But it's a good thing that I get, hopefully I get the jigglies out of the way before the actual contest. That's a silly mistake though. And the funny thing is that, to be honest, the funny thing is that if I didn't have this assert, I think technically it would actually pass. But that said, you want to make sure that, I mean, like, it would pass for this example, but then it would be not quite correct, right? It would just be that you're lucky that, you know, the constraints are true in a way such that your thing passed, but it doesn't mean that, you know, like there's no way around it. I was being sloppy, I think is my answer, right? Basically, the assert allow us to have these what's it called? Like a precondition, right? Which I violated, which is that when you check in, the person is no longer check in, but that's because I forgot to check out. Yeah. So I think this is I mean, it still suck if you're on a contest and you get a one-time error, even though this is like mostly right and you kind of brought it to yourself. But it's also good for debugging, right? Because I don't, like, if I didn't do it this time, but if I were to be debugging, then maybe it could be a little bit better. So yeah, that's all I have for this one. Let me know what you think. Yeah, because these things will help you debug, especially as you write more and more code. I mean, maybe this is small enough that, you know, but yeah, that's why you try to remain consistent. I guess let me go through the complexity really quick. This is also another hash table problem, hash set problem for the rest of the, just like the rest of the week or whatever. So everything should be O of 1. Let's take a look. I mean, this is just initialization. This is O of 1. All these are O of 1, and this is O of 1. So yes, everything is constant. Everything should be fast. That's why I didn't even look at the constraints really. Though maybe we should, just in case. This isn't even that. This okay, this is the big one, the number of cores, but everything's constant, so it should be okay. Yeah, anyway, that's all I have with this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see you later and take care. Bye bye.